Oh, I got cut off. Ran out of time. All right, so as I was saying, the O2 sensors only kick in when CO2 levels are normal, because if they had increased, normally when O2 levels go down, it's because CO2 levels have gone up because you've been more active or doing something. So cell respiration is happening, you're burning food, oxygen is being used up, and CO2 is being made. So if the CO2 levels are normal, but oxygen levels are low, then we have to have a way of noticing that too. So that's when the O2 sensors kick in. And again, that could be when you're at a higher altitude, like on a mountain, or when you're exposed to carbon monoxide. Now, you probably know a little bit about carbon monoxide, but carbon monoxide is it's produced whenever we burn fuels and they don't burn completely. They don't go to completion. So when we burn fuels in our car, for instance, we have carbon monoxide coming out of our exhaust. If we're burning fuels to heat our home, then sometimes carbon monoxide could leak, and so we often have a carbon monoxide detector in our home. In any case, what happens is carbon monoxide has a higher affinity. That means a higher attraction for hemoglobin in your red blood cells than oxygen does. So even though you might be breathing well, if there's too much carbon dioxide around you, then the carbon monoxide is going to bump the oxygen off of your hemoglobin, and eventually, if you're not taken out of that situation, it can mean that your cells are not going to get oxygen and you could die from it. So years ago, when there were bad storms and people would get stranded in their cars, sometimes they would keep the car going to keep warm, but the snow would go around and cover the exhaust, and then the carbon monoxide would fill the car, and unfortunately it would sometimes mean that a person might die. The same kind of thing can happen in a house fire. The carbon monoxide that's being produced during the burning can cause a person to die before maybe the fire reaches them, or that sort of thing. So it's scary, and it's scary that that can happen. It's carbon monoxide poisoning is what we call it. But it's really important that we can detect that, increase our breathing, and as long as we get a good supply of oxygen back to us in time, then that we could recover from that sort of situation. So, like the other cases, we look at this through a negative feedback loop. That is how we regulate a lot of the things that happen in our body. So, normal conditions, we use the CO2 sensors. So let's say the perturbing factor was exercise. When you exercise, you need lots of energy for your muscles to work and that sort of thing. So oxygen is being used up and CO2 is being produced. So the perturbing factor is exercise. The stimulus would be an increase in carbon dioxide due to cell respiration. The sensors that are going to kick in are your CO2 sensors, because they're going to detect the increase in CO2, and they're found right in the medulla oblongata. So there's no need to send a message to the part of the brain because they're already in the medulla oblongata. So they're going to detect the increase in CO2, and because it's that part of the brain, it interprets the information and sends a message to the effectors. So those are the muscles that are going to deal with it. So it sends a message to the effectors, which are your diaphragm and intercostal muscles, and they will respond by contracting and relaxing faster, so they increase your breathing rate. Okay, now the response, remember, is to be the opposite or counteract the stimulus. So the stimulus was an increase in CO2. The real response is to get that CO2 down. Okay, so there's a decrease in CO2 as a result because it's exhaled. But the bonus is, at the same time, we're increasing our O2 because we inhale it. And when we get levels back to normal, then these earlier steps will be turned off. So that's under normal conditions. When instead CO2 is normal and oxygen levels are low, then the other sensors are going to kick in. So a lot of it's the same, but there are key things that aren't. So let's have a look. If the perturbing factor was that you're at a higher altitude or exposed to carbon monoxide, then the stimulus in this case would be a decrease in oxygen when carbon dioxide levels are kept normal. So there's no change in them. In this case, the sensory receptors that kick in are the O2 sensors that are found in your carotid artery and your aorta. So since they're not in the brain, they have to detect the decrease in oxygen and send a message to the medulla oblongata. The medulla oblongata, the integrator, will interpret the information and send a message to the effectors. So this part's the same. Okay, it sends a message to them, says, hey, we need to increase the oxygen level, so we need you to breathe faster, so contract and relax faster. And so they do. The response, the key thing about the response, again, it's to counteract the stimulus. So the response is an increase in oxygen since it's inhaled. Bonus is we're getting rid of the excess carbon dioxide that we have around, so it's exhaled. And when levels get back to normal, then these earlier steps will turn off. Okay, so the 6 things shouldn't be new. It's how we apply them to regulation of breathing. That's a little different. I think I will, this part we're going to save and do on the next video lesson.